talk about density. So here's how you use this video. When I'm going through, there'll be slides, and on those slides, there's going to be the green highlighted text. That's like the key ideas. If you're taking notes, you should write those down. Also, there's going to be blue text. Blue text are questions for you to consider or for you to answer. Now, also throughout this video, there's going to be a visual code that'll pop up on the screen and a verbal code said by myself. There's just going to be 3 randomly generated numbers. They can appear in any order, so pay attention. So let's get started. So, density. Density is the amount of mass within a certain volume. It's a measure of how tightly packed the particles are in an object. So if you look off to the right, you can see that there's 2 different blocks. They're the same size, same volume, but the dots are going to represent the mass, how much stuff makes it up, and how closely packed those dots are. That's going to represent the density, how compact those particles are. Now, the density of a material is always the same, no matter how much of it you have. So all iron has the same density. That's the example that I use. So if you have an iron nail, well, that's going to have the same density, the same compactness of a horseshoe, or the I-beams that hold up skyscrapers. Because it's made out of iron, it's going to have that same density. Now, the unit is just grams per centimeter cubed. So it's just the unit for mass divided by the unit for volume. And remember, 1 milliliter is 1 centimeter cubed. So if you're measuring the volume using displacement and you're measuring milliliters, well, that's also 1 centimeter cubed. So here's the equation for density. And you can see why the unit is grams per centimeter cubed, because the equation is just mass divided by volume. And you can see in the equation, it's represented by the Greek letter rho. It kind of looks like a lowercase p. But remember, in these equations, you're just solving for the unknown. It could be y, x, but in this case, well, density is going to be rho. This is also an equation triangle that I have that can show you if you're solving for the unknown, you cover what you do not know, and then it will give you the equation that you are looking for. So at this time, I'll go ahead and give you that verbal code. It's 768. So let's take a look at some density problems here, right? So before we even put numbers to anything, let's just take a look at these like density squares over here. So in these, the dots represent the mass, the amount of matter that is in that object, right? So imagine if I put this on a digital balance, that would determine how much. If each one of these dots represents maybe 1 gram, that would tell me that. So I went ahead and I counted them for you, because sometimes there's a lot of them and I don't want you to miscount. Now the volume is going to represent the size of the square, and the density is how compact those dots are, how close those dots are to each other. So these are questions that we should be able to answer if we're looking at the mass. Which one has the largest mass? Well, I count up all the dots, and the one that has the most is going to have the largest mass. And you can see that will be E. That's going to have the largest. If I put it on a digital balance, that would say the most out of all of them. And which one has the smallest mass? Well, that's going to be B, because it has the least amount of dots, the least amount of matter. I put that on a digital balance, it would say the lowest. Which two have the same? So I'm looking at those numbers, and I can see that C and F have the same number of dots. If I put those two on a digital balance, they would say the same amount. Now, the volume is the easiest one. That one's you just look at it and you can tell the size of it. So I know the largest is F, takes up the most space. The smallest is A, takes up the least space. The two that have the same volume are B and C. They're the same size. Now density, well, that one's just looking at it and saying, well, how close are those dots? Which one has the largest density? Look at C. C, those dots are really, really compact, right? It has the most density, right? They're the closest together. The one that has the least density is D. That you can see that those dots are pretty far apart. Now the two that have the same amount, that's going to be A and F. So you can see that if you laid them over, those dots are going to be the same amount. That would mean that they're the same materials, right? So like I said, remember, iron has the same density. No matter whether it's a nail, a horseshoe, or an I-beam, they're going to have the same density. So those two would probably be the same material, right? This is just a great representation of mass, volume, and density. Now let's calculate some problems. So I'm just going to set up a real quick, easy one. A block of bronze has a mass of 120 grams and a volume of 15 centimeters cubed. What is the density of the metal? So I want to go ahead, I need to find the density. I know the mass, and I know the volume. So here's how I use this triangle. I cover up what I'm looking for, density, right? Density equals, and I'm left with mass divided by volume. Divided by volume. So that's 120 grams divided by 15 centimeters cubed. And that's going to be 8 grams per centimeter cubed. Okay, that's a fairly easy one. So let's do this one. So I'll skip down through these two. So these are really the only 3 types of equations that I can give you, right? You can solve for density, you can solve for volume, and you can solve for mass. So this is how you would set those up. So this one, the next one, a rock has a mass of 300 grams, a density of 2.5 grams per centimeter cubed. Well, volume, you know the density, you know the mass. You're looking for underline volume. I'm looking for the volume. Well, that is going to be mass divided by density. That's what I'm left with. This next one, well, I'm looking for the mass, and I know the density, and I know the volume, so that is mass equals density times volume, right? So I cover up mass and I'm left with density and I'm left with volume. So, and I put the little multiplications out because they're next to each other, but you don't have to put that, but I just put that there just so I know which sign that I'm using there. So let's go over a couple of trickier ones here, right? Let's look at these bottom two. A block has a volume of 12 centimeter cubed and a mass of 32.4 grams. What material is the block made out of? So I'm looking for the material here. Now I know the volume and I know the mass. So here's the thing. I don't know the material just by looking at this, but if I can calculate the density, I can look up what material it is in a chart over here. So you can see that there's a chart right there that I can look that up. So in this one, I'm looking for the density. Density equals mass divided by volume. That's going to be 32.4 divided by 12 centimeters cubed. Oh, I forgot to put grams there, right? When you divide that out, you are going to get 2.7 grams per centimeter cubed. So if I look up here, that is going to be aluminum. So I know that it's made out of aluminum. Now here's another problem that I can give you. The next one, an object is made of iron and a volume of 6 centimeters cubed. What is the mass of the object? So I'm looking for the mass. Well, I know the volume, and I know that it's made out of iron. So I set that one up. I cover up mass, right? That's what I'm looking for. Mass equals density times volume. And so I just look up the density of iron. You can see here it's 7.9 grams per centimeter cubed. So those are the kind of problems. So there are some problems where you're going to have to look up the density or the material from a chart. So the question is, what determines if an object will float or sink? So it all does have to do with density. So if an object is placed in a medium or a fluid, right, it doesn't have to be liquid, it could also be air, that object will float if they are less dense than the medium. Objects will sink if they are more dense than the medium, and the density of water is 1 gram per centimeter cubed. Right? Now, like I said, some other liquids might have different densities, but this is how to tell if it floats or sinks in water. If it's less than 1, it's going to float. If it's more than 1, it will sink. And this applies to any water. This also applies to gases. This is how hot air balloons work. So hot air is less dense than the surrounding air, and it'll create that buoyant force that will lift. It's also why helium balloons float. Helium is less dense than the surrounding air. You let it go, well, it's going to float. So how do metal boats float then? So that brings us to buoyancy. So buoyancy is the upward force that a fluid pushes on an object placed in it. So if the buoyant force is greater than the object's weight, it floats. If the object's weight is greater than the buoyant force, it will sink. So boats are shaped to displace. So remember, push aside, right? That's what displacement is it's the amount of water that it like pushes, a lot of water. So when a boat pushes into that water, the water is going to push back up. That is the buoyant force, right? You can see there's that buoyant force pushing up on that boat. Now, as long as the average density of that boat, including the air inside, is less than the density of the water, it will float. So boats are mostly empty space. They're designed to push a lot of water away, so there's a huge buoyant force going up. Now, yes, if there's a hole in the boat, like a metal boat, well, then water pours in, and then it's going to be more dense than the surrounding water, and it's going to sink, just like this rock over here. So that's why steel ships can float, but a steel ball will sink, right? It's the same material, but different shape, and it just takes up volume, and the average density, including the air inside, is going to be less dense than the water around it, meaning it's going to float. So, just as a final thought, remember there's too much unknown in the universe to take a break from learning. Get out there and question everything.